Third time's a charm. All right. We might get interrupted by the directions lady. But, so, last week's videos were mostly concluded. There was one left that I wanted to do, and it was to talk about 2 experiments that I'm proposing. But before I do that, I wanted to propose a riddle. Not a, like, Baggins kind of rhyming riddle, but just a question. And I'd like to hear from your comments below. Let's see if you can guess what has been the most powerful, transformative, ubiquitous, involved in everyone's lives invention of the 20th century. I'll give you a hint. It's not the computer. So see if you can guess. Put it below. Alright, now, going on with our electric universe, I have 2 experiments I'd like to propose. The first is a really easy one to explain, and I do intend to do this one. Because I have these magnetic balls in my office, and they're like steel bearings. They're about this big. And what I'm proposing that we do is that we find a way to magnetically levitate these balls, and then basically use the plasma orb and establish an electric field pointing, mark on the ball what's north and south pole, and then just change the magnetics or change the orientation of the electric field. See what happens. Does the ball flip over? I mean, it seems to me it's kind of funny. Everybody's like, well, what will happen if the magnetic pole flips? Well, let's just do some experiments and find out. So I'm working through on how to do that. If you have some ideas about how to do this experiment, post them below. Still working through it in my brain. But it seems to me it shouldn't be too hard to create an electric field representing the power of the sun, and then to test out what would happen with a ball that had been previously, floating. And the other experiment is a little bit more complicated. So it goes like this. Because light does exhibit a wave-particle duality, well, then it should, if it's a particle at all, demonstrate the same effect that we see when we spray out particles. We should see concentrations. And when I look out at light, I don't see that. Okay, other than shadows, pretty much you get an even flux throughout the entire electric field onto the ground. Yet, if I have a defined region of release, if I can calculate how many moles of atoms are in that filament, and then I can calculate basically how many electrons should be flowing through that filament, because I can control the wattage and current, then I should be able to define on certain orders of magnitude the various the number of electrons that should be coming out of those moles of atoms, right? Which case, when I start with a small room, it would be expected that I could fill that room evenly. And so I can measure the luminosity of the reflection off of the walls. And I can also document in a perfectly white room how much spotting or speckling there is. And then if I expand the size of the room to then another size, or just basically take the boxes off of the experiment into a larger room, I can then compare the luminosity across those walls with the luminosity on the boxes or the smaller room, and I can also look for more speckling. And theoretically I could just keep going like this, right? And what I expect is that the drop in brightness will be mostly proportional to the spread of the area. So it should be sort of like how a voltage drops. The more resistance you add, that is, the more things you put in a circuit. And that would be my hypothesis, that there will be no speckling at all, and and it should be moving around too, right? Because it's waves, it should be rippling all about. But that realistically, that there is no speckling, and that there aren't really particles bouncing along. People say, well, how does light transfer momentum? Well, I've covered that in a previous video. Light transfers momentum via transferring angular momentum. That is, the rotation in the electromagnetic waves provides the angular momentum. That it's not actually particles bouncing off anything, because there's no mass in photons, so how can it be bouncing? So those are the two experiments I'd like to propose, and feel free to comment below about what you would do in those experiments, things that you think should be done to set up rigorous controls. And then also, like I say, I'd like to hear your thoughts. I mean, there is a right answer to this riddle. So again, what has been the single most powerful, ubiquitous, affecting everyone invention of the 20th century? Or actually, I guess it might have been invented in the 19th century. So we'll just say in the modern era, like in the post-Enlightenment, we'll say. So that'll help you to open up. You might start thinking, oh, you're getting suspicious now. You're like, it's not the television, right? It's not the television. So try it out and let me know what you think. I'll see you guys later on this week. I promise by then I'll be shaved. I'm heading off right now to the AKHA meeting, and I guess by the time you see this, I'll have already been to the AKHA meeting. Please consider joining the Ancient Kentucky Historical Association. It's only $10 for a household to get the newsletters. And oh yeah, look forward to. I have a small rant video I'm going to do about the archaeology visit that I did this last week to the Webb Museum, which, by the way, scored an atrocious score on my ranking data. Scored like 65% or something. It was really bad. So look forward to that, and also some health videos this week. I hope you have a good rest of your day, and I'll see you later.